A sphere with mass 4 kilograms is held at rest on a smooth, inclined surface by a horizontal string, as shown in the figure. The inclined surface makes an angle of 37 degrees with the horizontal. What is the magnitude of the force exerted on the surface by the sphere? So, first, we know that the force that the sphere exerts on the plane is the same as the force that the plane exerts on the sphere by Newton's third law. And so, the normal force due to gravity acting on the sphere will just be mg cosine theta, and then we're also going to have to account for whatever normal force is there due to the tension in the string. So let's draw the components of this tension with the angled plane that we have. And yes, the x-axis is supposed to be parallel to the plane. That was just a drawing error. So now let's label that force T, and so that angle will also be 37 degrees. So there's a vertical angle. And so that right there will be T sine theta, that vector right there. So plus T sine theta. But the problem is we don't know what tension is, right? And so I might write it as theta, I might write it as 37 degrees, but know that they both mean the same thing. And so the net force is equal to 0, right? So this is important to help us find what T is. So notice, because the ball isn't moving, right, there's a force in the x direction of mg sine theta, and a force going up of T cosine theta. So T cosine theta is going to be equal to mg sine theta. Oh wait, is it T tangent theta? T tangent 37 degrees equals, sorry guys, I think I'm just kind of confusing myself here. I was right the first time. Tangent of, T times cosine 37 degrees equals mg sine 37 degrees. Alright, now we have it down. Okay, so now just divide both sides by cosine 37 degrees, and you get that tension is equal to mg tan 37 degrees. So now we can just substitute that in here. We get that the normal force is equal to mg cosine of 37 degrees plus mg tan 37 degrees sine 37 degrees. Now, there's a nice AP Physics shortcut to any trig function of 37 degrees, where sine is 3/5, cosine is 4/5, and tangent is 3/4. And if you were to do that and then approximate g as 10 meters per second squared, you would get around 50 newtons. But if you were to plug this all into a calculator and use g as 9.8 meters per second squared instead, then you will get approximately 49.1 newtons.